Today I want to show you how to build a full-length blockchain application that mixes a bunch of different technologies together. Okay, we're going to use Ethereum. We're going to write smart contracts, the Solidity programming language. We're going to use IPFS, the interplanetary file system, for decentralized file uploads. And we're going to mix these two things together to create a decentralized app that does file uploads, handles files, all that kind of stuff. Okay. And before we get into all that, hey, I'm Gregory from Dapp University. Click the like button down below, click subscribe, and if you want to learn how to build blockchain technology, you need to join my free training on my website over at dappuniversity.com/bootcamp. So there are several different technologies we're going to combine for this video, okay, and this project. The first one is Ethereum. That's going to be the blockchain protocol that we use for this application, right? It's going to be our backend for the app, essentially, okay? Another one is IPFS. So IPFS is the interplanetary file system. This is what's going to allow us to actually store files in our application in a decentralized way. Okay, and the other technology is React. Okay, this is going to give us the ability to write a client-side application for the project without having to write a bunch of JavaScript boilerplate code ourselves and, you know, do a bunch of yucky stuff in JavaScript. So React is a really great framework for building user interfaces in JavaScript, and that's what we're going to use in this tutorial, right? So you don't have to be an expert in any of this stuff. You don't have to really know much about blockchain or the programming languages involved or React or anything like that. I'm going to teach you everything from scratch, okay? So let's go ahead and take a look at the app that we're going to build, all right? So this is the meme of the day app, all right? So essentially, this allows, you know, somebody to set the meme of the day. Right, here's today's meme, and you could change this. You could choose a new file and upload it and, you know, pick a new one and change it. And then click submit, and it would change this meme, all right? So I'm not going to demo that all the way through, but that's how it works. So yeah, what this app does is this client side is written in React.js, and, you know, we've got Bootstrap, this the templating framework that makes it look, you know, nice. We're not gonna have to write a bunch of CSS and JavaScript and extra code just to make it look like this. We're gonna get a lot of that for free. All right, so yeah, it uses Bootstrap, uses React.js to handle all this rendering, you know, the uploads, the submission, all that kind of stuff. React handles all that. And two other pieces, right? We've got IPFS, that's where the file goes, okay? So whenever we upload this file, it actually goes to IPFS, and then when it comes back from IPFS, it gets saved on the blockchain, right? And that's what we're using Ethereum for. It's got a smart contract that we're going to create in this tutorial that tells our project, our backend, where the file is located on IPFS, all right? I'm going to give you a diagram of how that works here in a second, okay? But let me first explain IPFS a little bit more and why we're using it in this tutorial. Okay, so IPFS, like I said, is the interplanetary file system. And essentially, like, this is a solution for storing files in a decentralized way. So what do I mean by that, right? So the whole point of building a DApp is to try to achieve decentralization. It's try to remove a central authority, a central point of failure, you know, from an app to make it more trustless, all that kind of, there's lots of different goals you could shoot for. But the whole goal is to try to move away from keeping everything in one place, right? That's what IPFS does. So, you know, Ethereum is the blockchain that we're using. Ethereum has nodes, you know, that keep a copy of all the code on the blockchain. That's how it works, right? All the data and the code's distributed across the network, but it's not a great place to put files, right? Files are big, right? So you don't want to store like megabytes and gigabytes of files on Ethereum. It would be cost prohibitive. It'd be so expensive to do that. And it'd be so slow, and like it just wouldn't even work. So you need something else, right? That's what IPFS comes in. So essentially it has nodes like Ethereum does, and you distribute files across different nodes on the network, right? And they can't be, you know, tampered with, just a lot like Ethereum, right? If somebody changed it, you wouldn't have this, you'd have a different copy, and therefore there'd be a discrepancy, and yeah, you get the idea. So IPFS is a decentralized file storage protocol, and that's exactly what we're going to use. So IPFS uses hashes. So essentially, whenever you upload to IPFS, the file will live somewhere, and then you identify it by its hash, okay? So that's what we'll store on the blockchain, okay? So in this app, I'll show you on the whiteboard here. we're going to upload an image, put it on IPFS, get the hash back from IPFS, and then store that on the blockchain. Okay, so I'll show you. We'll basically take an image first, and then we'll have our browser, and then we'll have let's see, IPFS, and then we'll have Ethereum smart contract. Okay, so what's going to happen is we're going to have an image, a meme, right? We're going to upload it to the browser, okay? And once we have done that with this form, right? Here's the form, upload the image, choose file, submit, all right? It's going to go to IPFS whenever we submit the form, okay? And then once the file is actually stored on IPFS, it's going to come back with a hash, okay? And whenever we get that hash, I'll just write that here, hash, we're going to store that hash on the blockchain, okay? And then whenever we reload the app, we will fetch that hash back from the blockchain, and that's how our browser will know what the meme of the day is. All right, so the meme of the day will always live on the blockchain, and whenever we refresh this page, it's going to fetch that data from the blockchain, show us the meme of the day, and that file is going to be rendered from IPFS, right? So that hash on the blockchain can't change, and then the file on IPFS won't change either. Okay, so it's going to be a decentralized application. All right, so one more reason I'm using IPFS and making the tutorial this way is to really just show you how file uploads can work in a decentralized way. So I know this is a little bit of a silly app, right? Just to kind of make a meme of the day on the blockchain that doesn't necessarily make sense for a real world use case. Part of it's educational and entertaining, but it's also just show you how it works, right? This could theoretically be any file. Like what if this wanted to be a medical record or something like that? And you'd have to take this example and extend it and do some more things like encryption, et cetera. But this gets you started, and this shows you the power of decentralization and what you can do with it. And you can take this example and build on top of it, right? Use any kind of file that you want to, right? That's why we're doing this tutorial. Okay. All right, now let's go ahead and install the dependencies so that we can start building out the project. Before you get started, you need to make sure you have Node.js already installed on your computer. You can see if you have Node installed by going to your terminal and typing node-v. You can install Node with a package manager like Homebrew, or you can download it directly from the Node.js website. The first item in the Blockchain Developer Toolkit is a personal blockchain. We're going to use Ganache as our personal blockchain for this tutorial. You can head over to truffleframework.com/Ganache to download it. You can click this download link, and whenever you've downloaded it, make sure you install it. And when you open it, you've got a local blockchain running. So what is Ganache? What is a personal blockchain? Well, a personal blockchain is like a real blockchain network, that's connected to the public where anyone can connect to it, but it runs on a computer. It's, a closed network. And Ganache basically, is a process that runs on a computer that spins up this blockchain and runs on a server. So we can use this to develop smart contracts. We can run tests against it. We can run scripts against the network, develop applications that actually talk to this blockchain. And it's really helpful, and it's an invaluable tool in the Blockchain Developer Toolkit. So if you open Ganache, you'll see 10 accounts listed here. These are the addresses to each account on the side, and you'll see these balances. You'll see 100 Ether. This is the Ethereum cryptocurrency that each account has, and is required to pay gas fees in the network and stuff like that. All right, so that's an overview of the Ganache personal blockchain network, and we're going to leave Ganache here set up in our project because we're going to need it running in order to develop our project. The next dependency is the Truffle framework. We're going to use the Truffle framework to develop Ethereum smart contracts with the Solidity programming language. You can install Truffle by going to your terminal and typing npm install-g truffle at 5.0.5. And it's important that you use that exact version in order to follow along with this tutorial. So Truffle is a suite of tools that allows us to, develop smart contracts, write tests against smart contracts, deploy smart contracts to the blockchain. It gives us development console, and it also allows us to develop client-side applications inside of our project. So it does a lot, and I'm going to show off all those features in this tutorial. The next dependency is the MetaMask extension for Google Chrome. Remember that the Ethereum blockchain is a network, and we need a special browser extension in order to connect to that network. And that's where MetaMask comes into play. MetaMask will allow us to connect to the blockchain with our personal account and actually interact with the smart contract that we'll develop in this tutorial. You can install MetaMask by going to the Google Chrome Web Store and searching for MetaMask and clicking install. And once you've installed it, just make sure that you enable it inside of your Chrome extensions like this. You can also see the little fox icon in your extensions tab. All right, let's get started coding. So the first thing we need to do is get the project set up, all right? And instead of creating the project from scratch, I'm going to use my starter kit. You can see this on GitHub. This is Dapp University, github.com/Dapp University/starter kit. All right, we're going to use this. This is a custom project that I've created with the Truffle suite. And I've also included like a React app inside of here, and I've added some special configurations so that you can keep all your code organized really well and stuff like that. And basically, this is just going to allow us to get started quickly without having to write a bunch of code ourselves. So I'm going to copy this URL, and I'm going to go back to the terminal, and I'm going to say git clone, all right? And then I'm going to paste in the URL, and then I'm going to hit space and the project name. So I'm just going to call this meme, all right? All right, there we go. So now we've cloned the project. I'm going to go into that directory like this. We'll say cd meme. All right. Now we can see that there are files in here. All right, we've done this correctly. So I'm going to open this in Sublime Text. That's going to be my code editor. All right, with the symlink subl dot. All right, if you don't have this configured, that's okay. You can just open the project manually, or you can find the Sublime Text symlink. Let me see if I can find it really quickly. Sublime Text symlink. Let's see what Google says here. Yeah, you could look up something like this to, subl, right? So if you're on a Mac, you can look at it this way, or you can just Google on Windows, like how to set that up, right? So I'm going to open this up, and now we can see that our project is here, the project directory. So we can look at the source directory and see that we've got some React components inside here already, all right? And we've got a contracts directory for the smart contracts on the blockchain. And we've got a truffle-config file, which has configured our entire project with some customizations. We can go over there in a minute. And then also a package.json file with the dependencies. All right, so let's go ahead and install the dependencies like this. So say npm install. All right, so that's finished. Now, if you see some errors here, it's okay as long as you have the success message at the end that all your packages were added. That's all you really care about. I know there's some issues here. I might work through those in the future, but this is working for me now, and it's working for everybody else. All right, so I'm going to clear this out. And really quickly, just a quick recap, this package.json file is basically just a way to pull in all the libraries, the JavaScript libraries from the NPM registry that we need for our project. They're going to give us packages or just like libraries and reusable code that's going to do stuff like allow us to talk to the blockchain. That's what Web3 is right here, right? Web3.js turns our web browser into a blockchain browser and lets our app do that, right? Truffle's the suite of tools that allows us to, actually build this project out like this, right? It's a React, et cetera, Bootstrap, right? All right, so let's go to our terminal. I'm going to open a new tab, and I'm going to go ahead and start our web server because we have a free web server that came with this project, okay? And I'm going to show you what we got for free with the starter kit. So I'll say npm run start. Oops, sorry, npm run start. All right. So you should see your web browser pop up whenever that happens, right? Because it's going to say starting development server, and it'll go ahead and open a new tab or a new browser window if you haven't opened one yet. And you should see your app open automatically. All right, there we go. This is the Dapp University starter kit. This is what we got for free whenever we cloned that Git repository right here. And this is all the stuff that's in here. You can see we've got Bootstrap, right? That's what gives us this nice dark nav bar. Got a logo inside here and some basic code, right? So we can, I'll show you where all that lives inside the project. If you go to source components, right, we can see this app.js file here. This is a big React component. That's got all of the code for that starter kit. We can see, Dapp University here is here. That's in the nav bar, right? That's what's everything inside this nav. Okay. Nav. This is Dapp University. And we can see, Dapp University Starter Kit. That's what's going on right here. All right, we see the logo, and this is a link to dappuniversity.com for my bootcamp. And yeah, there you go. So we can edit all the code on this page as a starting point to create our meme app, okay? So I'll go ahead and do that. Let's just change this. We'll say meme of the day. I guess can do that. All right. Meme of the day. All right, really quickly, I'll go ahead and explain React.js if you're not familiar with it, okay? So React is a JavaScript library for building user interfaces. And essentially, what React does is it gives us a way to organize our code, right? So React organizes all of its code in these things called components. That's what app.js is here, right? So you see this class extends component, right? So components coming from here. And this is being imported from React, okay? So components are basically ways to just organize your code so that they're reusable, so that they're compartmentalized, right? It organizes the code. You could have a bunch of different files here, and this would be different components that you could import like this and include inside of here, okay? And you can even see that, right? React is a component-based library. This is what a React component looks like in a very simple expression compared to what we just saw in our other project, right? And React gives you a couple other cool things like its state object, which we're going to use in this tutorial, right? So what is state? Well, state basically tells your browser, it's hard to define the word state without using the word state. So let me just show you here in this to-do app, right? So over here in this to-do list, we can see item 1, right? Add, item 2, all right. So in this case, if I refresh the page, item 1 and item 2 would go away, right? And that's because this to-do list has a state. Well, the state represents what items are on the to-do list, right? And if this was a more advanced to-do list, it would have checkboxes and you would know which items were completed and which items weren't completed. All of that would be the responsibility of the state to know that information, right? And React gives us this state object right here, right? This says items. This is, the items that are on the to-do list, and this is the text for the to-do list, right? So React has a lot of cool features that allows us to work with this state object as we're going to see in this tutorial, okay? And React also has, some lifecycle methods and stuff like that. There's a lot of cool stuff we get for free out of the box with React. But that's a high-level overview of what it is. If you've not used React before, don't be scared. We're going to, get our feet wet with it in a pretty beginner-friendly way in this tutorial, okay? All right, so now let's go ahead and start actually, changing the code and making this work. Okay, so what I'm going to do, I'm going to do this a little differently. I'm going to actually work on the front end part of this application and then work on the back end after we've gotten some of the basic front end functionality done. And there's a couple reasons I want to try that. I want to show you kind of how IPFS works first and get some visual feedback. And then we're going to work on the blockchain side of things second. Okay, and then we'll kind of glue it all together at the end. So that's where we're headed. I'm going to edit this to get the front end working to actually integrate IPFS. And on the back end, we're going to use the blockchain. Then we'll put it all together kind of in part 3. Okay, so let's go ahead and get IPFS working. The first thing we'll do is take out, some of this. We don't necessarily need this link anymore. Let's see here. Take this out. And, whoops. I think I took out too much code here. And let's refresh the page. Yep. All right. So essentially what we want to do is change this image. And we want to create a form here that uploads a new image, puts it on IPFS, and then whenever it's on IPFS, we want to show the image here, right? It's going to replace this logo. All right, that'll be our meme of the day. Whenever users see this page, they'll see the new meme here, okay? So let's go ahead and create that form. We'll do it like this. I'm just going to create a form object here. Let's see here, right below this. It's a form, all right? And I'm just going to do like this. I'll say input, type, file, all right, and then on, And that'll just do that. And I'll do another input type submit. All right. Go and refresh the page and see if anything changed. All right, perfect. Okay. So what we're going to do is choose a file and then submit it. And whenever it's submitted, it's going to go to IPFS. And then whenever it's on IPFS, it'll show it here. Okay. So now let's go ahead and add some formatting to the code. Okay. We'll add a, let's say H2. Let's say change meme. All right, go back here, change meme. Perfect. All right, now let's add a little space here. You could probably do this with Bootstrap. Let's try this. Let's say, well, I'll do it like this. This is kind of a cheating way to do it. This is just an HTML entity for a non-breaking space inside of a paragraph, which is going to show just, oops, I spelled that wrong. NBSP. All right, there we go. Just going to give it some space between the logo and the title change meme here. All right, there's a better way to do this with like CSS and Bootstrap, but I'm just going to put it here for now. Okay, so now we have our UI laid out. This is going to be the meme whenever it's changed. Here's change meme. We're going to choose a file. We'll click on submit. Okay, so let's go ahead and actually upload the file. So the first thing we want to do is create an event, create an on-change handler. All right, so on change, we want to capture the file. We'll say this.capture file. Okay, and I'm going to put a space here. Okay, so what's going to happen is whenever we choose the file, we want to upload the image and then basically process it so that it can be sent to IPFS. We actually want to convert it to a buffer, and I'll explain that here in a minute. But essentially, whenever this file field uploads a new file, we're going to process it, right? It's a two-step process. Process the file, and whenever it's submitted, we'll have a new event handler that puts it on IPFS. So let me explain the event handlers. Essentially, what's going to happen is this says whenever the input changes, call this function, okay? And now I'm going to define this function. I haven't defined capture file yet. I'm going to do it up here, right? So on change this.capture file, okay? So let's go here and say capture file. All right, create a new function like this. Oops. And inside of here, I'll just say event. Okay, so I'm going to use a JavaScript arrow function here. All right, it looks different from this render function. And that's because, for a couple reasons, the function scope is different, and it prevents me from having to do some other binding inside of JavaScript and React. I don't want to get too deep into that, but essentially I'm using an arrow function here for a very specific reason. Okay, so also notice this render function inside of React is just the function that's called whenever this thing lays content out on the page, and it basically allows you to put all this HTML with JavaScript mixed inside of it onto the page. I didn't really explain that before. Sorry. So this is a function that has JavaScript, and you can basically mix HTML and JavaScript inside of it. That's really what React is all about. So you can see this is JavaScript right here. This is JavaScript. Oh, sorry. Well, this part is, but this is HTML. All right. So let's keep working on this capture file. So inside of here, what we want to do right now is essentially just console log that the file has been captured. So log file captured. And I'm also going to say event prevent default. All right, I'll explain that really quickly. So event is going to be the argument for this. So on change has a callback function essentially, and it's going to pass in an event. And we want to prevent the default behavior. So like on submit or something like that, it would go to a new page. And different elements have different default behavior whenever they're submitted or changed. And we're just going to stop that. We want to override that behavior and create our own here. All right, so that's what I'm doing. So what's going to happen now is just verify that this is actually wired up and talking. Okay, so I'll click choose file. All right, and I'm gonna actually choose a meme. So I'm gonna hit that, hit enter, and let's open the console to see if it changed. Yep. All right, there you go. You can see file captured. Boom, done. All right. Yeah, perfect. Okay. So now what we want to do is build this function out. We want to process the file inside of here. Say process file for IPFS. All right. So there's a few things we need to do. First, we want to fetch the file from the event. We'll say event dot target files. All right. So let's actually console log that out. It's actually, I'm going to take this off and show you. Event.target.files is what we want. So we're reading event here .target.files. Let's just console log that. Choose a file. Change it. All right. All right, here we go. So file list, right? You can dig into this and see, yeah, there you go. It returns an object with keys. And we can see here's the file information. Last modified, modified date, name, size, image, right? All this stuff. So it's a file object, okay? And we want the first one or with the key 0. So that's what we do. We say event.target.files and we're going to read the key of 0, okay? So I'm gonna do that. Paste it here. And then that's gonna be our file, say const file, right? And next we want to say const reader equals new window.file reader. Okay. So this is something that's included in our project already. This is the file reader. Essentially what this is going to allow us to do is convert this to a buffer. All right. And a buffer is what we need in order to put this file on IPFS. All right. So I can show you what that is. Let's see, file buffer. All right, so you can read this on Mozilla here. It says file reader object lets web applications asynchronously read the contents of files or raw data buffers stored on the computer using file or blob objects to specify the file or data to read. All right, so you can read more about that if you want to, but that's essentially what we're doing right here. All right, so we're gonna take the file reader like this. And we're going to say reader, read as array buffer, and then pass in the file. Okay, we set here. And then now we'll say reader on load end. All right. And then we're going to do this, the arrow function, and say console log buffer, and then say this.state.buffer. All right, so let's just go ahead and take a look at that. All right, so choose a file, go here, open a screenshot, click enter. All right, so we got an issue here. Cannot read property buffer of undefined. All right, so sorry guys, and I haven't assigned it to the state just yet. Let's do this, my bad. We'll say we actually have to convert it to a buffer. So we'll do this, say buffer, reader.result. All right, try that again. Open the file. All right, there you go. So this is what the this is what it looks like. This is the data that we're actually going to send to IPFS. Okay. So we've done the job we need to do here. We've converted this to the format that we want. And then now we need to actually use this converted format. We've processed the file essentially. And we want to put it on IPFS. So it's a two-step process, like I said. Whenever you upload the file, we process it. And then we submit the form like this. Okay. So in order for these two things to talk to one another, you know, the submit button has to know about the file. Okay, so this is where React state object is going to come into play. we're going to take this content right here. This is the result that we want. And we want to put it in React's state object. Okay. So we'll say this.state, or sorry, this.setState. And we'll say buffer. All right, and put it in like this. Boom, done. All right. So I'll illustrate that. If you go back to React, I'm going to open the React documentation here, reactjs.org, and you'll see the state object. Boom, right here. This.setState, right? And you pass in whatever you want. And we can also configure the state inside of here like this. Inside the constructor. So the constructor props, we can actually just copy that, go inside of here and create a constructor for ourselves. Put it at the top. Super props. And we can add a default state like this. I'm going to take out some of this and say buffer. I'm going to say null. All right. And I'm actually going to break this up into multiple lines because we're going to add more things here later. But that's what I'm going to do. Say buffer is null initially, but we're going to set buffer here when we say this.setState and pass in the buffer that we configured right here. Okay. And this is going to allow us to read the buffer whenever we submit the form. All right. So we have on the input chain, captured the file, and we've essentially processed it. Okay. So now what we want to do is actually submit the form. And whenever we submit the form, we're going to put it on IPFS. So we'll go to our form and we'll say, let's see here, on submit. Actually, don't do it here. Let's do it on the form itself. Say on submit. Let's see here, this.on submit. All right. So we said this.capture file and this.on submit. So instead of right below capture file, we'll say on submit. And we'll do a new function just like we did here, event. Okay, so same sort of deal. We'll say event.prevent default. And then we'll say console log. Submitting the form. All right, so now let's try that. Choose a file, click a file, submit. All right, submitting the form. And let's go ahead and start putting it on IPFS. All right. So in order to connect the project to IPFS, we can do it a couple different ways. So just a quick recap of how IPFS works. It's a distributed file system, right? So it works kind of like a blockchain in the sense that it has a bunch of different computers that all hold copies of the files, right? So we could essentially be one of those computers, or we could just connect to one, right? So IPFS uses nodes, a lot like a blockchain, a lot like Ethereum. So similarly, like we could connect to IPFS by running our own node, or we could just connect to one for free, all right? So I don't want to go through like setting up your own IPFS node in this tutorial, because it's really easy to get hung up on something like that. I've got some other tutorials on my channel about that if you want to find those. I'm going to go ahead and connect to one for free with a service called Infura, okay? So Infura essentially is sort of like a blockchain as a service platform. Or not really blockchain as a service, more like a blockchain node as a service, and also IPFS as well. Okay, so you can use Infura to connect to Ethereum or IPFS. So it's really easy to get started with IPFS. You don't even have to create an account. You can just use the public Infura IPFS gateway, and that's exactly what we're going to do. Basically, we're just going to get a link to an existing IPFS gateway and node for free without having to register, and we just paste it into our project and it's going to work. Okay. So in order to connect to that, we need to install an IPFS package. Okay. So the package we're going to use is the IPFS HTTP client. All right. So here is an example. this is the npm registry page. Yeah, so this is the package we want. So we do npm install IPFS-HTTP client. We're just going to copy this exactly from the project. Okay. So we'll go to our code and say npm install --save IPFS-HTTP client. And let this install. And I'm going to go ahead and kill the server because I want to restart that whenever we install new package.json files. All right, or anything that goes in our node modules directory. Okay, and we'll check the status of this. All right, there we go. It's all done. So I'll go ahead and restart the server, npm run start, and we can go to our code and check our package.json file and see that indeed IPFS HTTP client was added to our package.json file. Okay. All right, so let's go back to our code, or sorry, our app, make sure everything's working. I'll refresh the page. Sorry, let's see, it's gonna ask me to run this on a different port. Say yes. All right, so we're all good. So let's go ahead and wire up our IPFS connection. Inside our app.js file, I'm going to import that new library like this. Okay, we're just gonna use the instructions that are inside of this documentation. Okay, so let's just do this. IPFS client equals require IPFS HTTP client. Go to the project like this. Okay, paste that in. I'm gonna say const. All right, and we could clean this up, guys. Just a heads up. For the sake of this tutorial, I'm just going to do everything like long form inside this one file. You could certainly optimize this. Like inside my blockchain developer bootcamp, we have a whole bunch of React components, and I teach you to build a full stack app with best practices and all that kind of stuff in a lot more depth. But for now, I'm just going to do it this way. Say const IPFS client. Say const. So that's going to import the package, but let's actually create the connection. Okay. So this is saying connect to a host like this. All right. So paste that in. Say const. All right. So this would be if you were going to run IPFS locally with your own node, right? You'd connect to localhost port 5001, you'd use HTTP. Okay, so we don't want to do that, right? We want to connect to Infura, that's what I was talking about a minute ago, which is going to give us an IPFS node and a gateway for free. Okay, so I'll do that like this. We'll say, we're going to, instead of adding arguments here, we're going to use a long way and say host. All right, we'll specify the host like this. We'll say port 5001, and we'll use protocol will be HTTPS. All right, not HTTP. Okay, so I'm just going to kill that, and we can actually see that in the documentation here. This was with arguments. This is with options, right? So that's what we're going to do. Okay. So we're using options here. So host instead of local host is going to be the Infura host. So we'll say IPFS Infura.io. Okay. That's the free Infura way to connect to IPFS. And this is a really easy way to get started. You don't have to create an account. You don't have to create an app or anything. You can just get started like this. Okay. So now let's actually connect to IPFS and put a file on it, right? Whenever we submit the form. So just to recap, we've chosen the file, we've processed it, we want to submit it, put it on IPFS, we have a connection to IPFS, and now we want to actually put this captured file on the file system. So we've got a submit handler. Now we want to use IPFS, and we want to add a file. So we have access to IPFS here, IPFS. And then how do we do that? Well, let's look at the documentation. We can see, let's see here, how to use it. Scroll down. Okay, so regular files, IPFS.add. Okay, pass in the data, options, and then it accepts a callback function. All right. So that's exactly what we're going to do. We're going to use the add function. Say add, and then we'll pass in the data, and then we'll pass in a callback function that will run, and we'll do stuff inside of here. Oops, sorry. All right, so do stuff here. All right, so what is the data that we want to put on there? Well, we want to get the processed file, right? So whenever we process the file, we set it to the state object, right? This.setState, and we said buffer, right? So that's what's going on. This is the React state object, and we want to read this buffer value, and that's the data that we're going to put on IPFS. Okay, so we'll say this.state.buffer. All right. And then the callback function is going to have an error. Oops, sorry. The callback function is going to have two arguments. The first one's going to be error. The second one is going to be results. All right. And let's just check that this worked. We'll say console.log IPFS results. All right. And we'll also say, like, if there was an error, let's tell the console. So if error, console error. Oops, sorry. Pass in the error, and then we'll return. All right. So let's see if it works. Go to the app. Refresh the page. Sorry, this is kind of slow. I'm not really sure what's going on here. Yeah, all right. Choose the file. Select our first meme. And click submit. All right, so submitting the form, we see that. Now I'll give you a heads up. Sometimes the IPFS gateway is a little finicky. So if it doesn't work for you the first time, you might just need to retry this. But it looks like it actually did work for me the first time. Awesome. Boom, there we go. So I can see the file was submitted here. All right. Here's the hash. And we can, this is all the data we need to access the file of IPFS. This is basically the ID of the file. All right. So I'm going to copy that. I'm just going to go back to our project and just paste, say example, and paste that in, okay? Awesome. So I know that doesn't look like much, but that's what we can use to pull our file off of IPFS. We know it's on there because that's what was successful, all right? So we're going to do stuff here later, and then I don't want to distract us too much, but essentially step 2 is store a file on blockchain, which we'll get to here momentarily. All right. So let me show you how to read this file off IPFS. It's pretty easy. Essentially, what we're going to do is create a URL, and this is going to be the ID of the file. Okay. So we can do it like this. So say sample hash, and I'll say example URL will be https://ipfs.infura.io/IPFS. All right. We're using the Infura gateway, just like we did here, ipfs.infura.io/IPFS/hash. Oops, sorry. /this. All right. And that is exactly how we can find the file. I'll just show you an example. Let's pull our browser back here. Copy this, put it in our browser, paste this in. Boom, there you go. There's our meme from IPFS. Ceiling cat is watching you work from home. So that's our first meme of the day that we're actually going to display inside of our app. Okay. So now we're going to use this URL and put it inside of the app, right? So we're going to replace this image with that. All right. So let's just copy this URL for now, and I'll just hard code it into this image. So image source, instead of the logo, let's just put that file in there like this. All right, boom. there's our meme of the day. Ceiling cat is watching you work from home. It's very disappointed in you if you do bad things when you're supposed to be working. All right, so that's awesome. Now we want to do is make this dynamic. Instead of just hard coding this and showing this image every time, we want to show, you know, the image we actually uploaded. And we can use React state object for that too, all right? So inside of here, instead of after buffer, we'll say meme hash. All right, and we'll just use an empty, you know, string here. And we'll visit the meme hash here. So say, we could say this.state.meme hash, state.meme hash, okay. And now refresh the page, and it's going to disappear. It's going to show us a broken image, right, which we expect because there's no meme hash yet, all right. So I'm going to take this away. All right, refresh the page. We shouldn't see any alt of logo at least. All right, cool. Broken image still, that's fine. We're going to take logo away so we don't need it anymore. All right. All right, boom. So it's not finding the image on Infura. That's fine. That's what we expect. But for now, we're just going to set a default value, a default meme essentially, of this. Oops. Well, we can paste this in, but take this back. All right. Or you could just copy the hash from here, or if you pasted it somewhere, yeah, whatever you want to do. So there's the default meme hash. All right, so that's the default meme of the day, and we can change it like this. So let's actually try to do it dynamically. So there's our default meme. Yeah, let's just see. All right, so now let's try to change this image, right? Let's post a new file to IPFS and then change this inside of our app, okay? So how do we do that? Well, we need to add a new file to IPFS, and we want to show the result, and then we want to update the state of the meme hash, right, to include that result, okay? So let's choose a new file. I'm going to choose a different meme this time. I'll just promise you it's different. Hit enter. All right, so there it is. Let's click submit. All right, submitting a form. It's putting it on IPFS. Let's hope it actually works. All right, there we go. IPFS result. There. So the result is an array here. All right, and we expect just one item to come back. So essentially what we're going to do is take the first object in this array, and we're going to take the hash, and we're going to save that to the React state, okay? So result is an array. So we can say const result, or let's just say meme hash equals result. So result is an array. We can read the first item in the array like this with 0, because arrays are 0 index, so 0 is the first item. All right. And then let's say this dot set state. Meme hash equals meme hash. Or in JavaScript, ES6 syntax, we can do this shorthand like this. So instead of saying meme hash colon meme hash, we can just do it all like this. All right, so whenever I set the state, it should update it, and React should automatically show a new meme on the page. That's how React state works. So anytime the state changes, it's going to re-render the page and show us a new meme. Okay, so let's try it. Let's change it. Let's put a new file in IPFS. Process, submit the form. It's submitting the form. And let's see if we get something new. Hopefully it'll post to IPFS correctly. If it doesn't, we'll just try it again. All right, so looks like we got an issue here. It worked, but I didn't actually do the meme hash correctly. Okay, so meme hash equals results. We actually want to get the hash. Sorry, guys. So I just returned the object. We actually want to get the nested key. So let's try it again. Choose file. Screenshots. Do a different one. Submit. Wait for this to work. All right, there we go. There's our new meme of the day. So we can see this is, let's just close this and enjoy our meme for a second. This is me and people walking slow. So this is a blimp of Yoda from Star Wars who's very disappointed at this grain silo. And this is a representation of me with people who are walking slow right in front of me. Okay, so we can change the meme still. It's just, sorry. Getting a little crazy here. Awesome, perfect. Okay, so it is working, but if we refresh the page, we notice, womp womp, it goes back to our default meme. All right, so that's what we're gonna use the blockchain for. We're actually going to store the meme hash inside of a smart contract on the blockchain permanently. That's gonna be our backend, okay? And that way, anytime we load this app, it's gonna have the latest meme of the day, not just what was stored inside of the React state object. All right, so I'll explain that more. So this React state object is really just in charge of keeping the client side state or the front end state, okay? And we actually have to keep track of the back end state on the blockchain because anytime someone visits this, we want to read the data from the blockchain and put it inside of this app, okay? So here, the only person that's going to know about this is us because we've got the code here, and it's only going to show whenever we load the page for the first time. Okay. So let's go ahead and do that. All right, we're going to just save this, and we'll start working on the blockchain part. All right, now let's go ahead and work on the blockchain part. Okay, so we want to essentially store this meme hash inside of a smart contract. All right, so we're going to create a new smart contract to do that, right? So we're going to do that inside this contracts directory, okay? You can see this migrations.sol file already here, okay? So what we're going to do is create a new file here. I'm going to say new file. So I'm using shortcuts in Sublime Text to do this. New file relative to current view. Okay, that's this same directory as this migrations contract. Okay. And I'll say meme.sol. All right, so meme, capital M.sol. So we can see the new file created here, meme.sol. So essentially, SOL is the suffix for the files that contain Solidity. That's the programming language used to write Ethereum smart contracts. And, you use the convention of capitalizing those. So this smart contract that already came with Truffle is essentially just the smart contract that's responsible for putting new smart contracts on the blockchain. I'll talk about that more in a minute. But we can create a new smart contract like this. First, we declare the version of the Solidity programming language we want to use, right? That's what this is. So we say pragma Solidity. Sorry, I'll just do it like this. Pragma Solidity. And let's see what version we want to use. Let's use the version that comes with Truffle currently. All right, so okay, cool. So let's use version 0.5.0. So say version Solidity 0.5.0. Okay. All right. So now we can actually create the smart contract inside of here. We'll say contract. This is how we declare smart contracts. We give it a name, meme. This is going to be the same name as the file. Then we use some open and curly braces like this, and then the smart contract code goes here. All right. So let's go ahead and try to compile this to make sure it worked, make sure we declared this properly, and the contract has a name, that our project recognizes it, et cetera, et cetera. We'll go to the terminal, and we'll say truffle, compile. That's going to basically just turn our smart contract source code that we write into bytecode that can be run on an Ethereum node and actually stored on the blockchain. Okay. All right, so it worked. No issues there. Now what we want to do is actually write the code for storing the meme hash. So all this contract needs to do is act as a storage for us, okay? Basically, it just needs to know how to take the hash that came from IPFS and put it on the blockchain. So that's a write function, okay? And then it needs a read function to actually get the hash back off the blockchain and deliver it to our client-side application so we can see that meme every time, all right? So it's just got two functions, read and write, right? Or we'll call it set and get, all right? So a read function and a write function. And we're actually gonna do the write function first. All right, so what we wanna do is create a way to store that on the blockchain. So the first thing we'll create is a state variable, all right? So a state variable is a variable for the smart contract that's going to correspond to storage, all right? So what does that mean? Anytime we update the value of the variable, it's gonna get written to the blockchain, all right? So we can create a state variable like this, a string name, all right? Or instead of name, we'll say, say variable name, essentially. That I just a dummy variable name, right? So Solidity is a statically typed language, and we need to use the data type of the variable before when we declare it. So it's always going to be a string, so you tell it string, and then here's the variable name. So in this case, it's going to be the meme hash stored on the blockchain. So we'll say meme hash. All right. So this state variable kind of works like a class variable in an object-oriented context where this belongs to the entire smart contract, not just locally to a function or something like that. Okay. So let's create a function to actually update this, right? And like I said, this value is stored on the blockchain, sort of like a database. The blockchain is going to be a database for us, and this is going to be essentially an attribute for this meme contract that we're going to update. So say function set. Oops, sorry. And then that's the function is going to look like this. All right, that's the basic building block of the function. There's the skeleton, I should say. And we need to add some more code here. Say string, and this would be the meme hash. All right, so this is going to have one argument. That's going to be a string, and it's going to be the meme hash. And then we're going to take this local, it's going to come in as a local variable. We're going to take the local variable and assign it to this state variable right here and write it to the blockchain. Okay. We simply do that like this. We say meme hash, right? This state variable meme hash, right? We're going to assign it is equal to this local variable meme hash. So meme hash. All right. So there's nothing magic about using an underscore here in Solidity. It's just a convention that tells you that this is a local variable and not a state variable. I mean, you could technically have an underscore here, work just fine. But I just do this so that we don't have naming conflicts and you know that, hey, this is a local variable, this is a state variable. We're taking this argument, which is a local variable in the function, and we are assigning it to the state variable. Okay. So that's the basic way we do this. We need a couple more things in order for this function to work. Right now, we can only call this function inside the smart contract, okay? But we want somebody else outside of the smart contract to be able to use it. So we'll say public, all right? That makes this function accessible outside the smart contract so that it can be called by somebody, who had access to it on the blockchain, okay? And then also because of the new version of Solidity 0.5.0, we need to use memory here, all right? So string, memory, meme hash, all right, is this. All right, perfect. So here's our write function. And then let's go ahead and compile this, make sure everything's working. Truffle compile. And if it compiles correctly, we will go ahead and move on to the read function, but I just want to make sure we didn't make any errors in the code before you guys see that. All right, it worked. So let's create the write function as well. Or sorry, the read function, like this. Say function, say get. All right, this doesn't need any arguments. And essentially what all this function would do, all this function would do would be get the value of meme hash here. We could just say return meme hash, all right? Pretty simple. But we need a few other things. We need it to be public, just like this. I should mention, this is called the visibility, all right? Public visibility. So public. And we also need to tell Solidity that this is a view, all right? So this is a modifier. And then also returns whatever the return value of this function is. In this case, it is a string. We also need to tell it that it's memory, just like this, because of this new version of Solidity, 0.5.0. All right. So yeah, that's it. And we return the meme hash. That's all you need to do. This is our entire smart contract. Let's make sure it compiles before I before I speak too soon, right? But if that works, this is all you need to do. It's pretty simple. Just a write function and a read function. And if this compiles, what we're going to do next is actually put it on our local blockchain and show you how it works inside the console. Run a test, and then we'll hook it up to our client-side application to work as our back-end storage for our memes, and we'll wire everything together. All right, it worked. So now let's put this smart contract on the blockchain and work with it. Okay. So what I need to do is first open Ganache. All right, this is your personal blockchain. Start it. You can create a new project or create a workspace. I recommend just doing the quick start. And then you should see your blockchain running just like this. You can see your mnemonic at top. You can see your address. Here's 10 accounts that you got for free. They all have Ether in them. This is just fake Ether. It's not worth anything on the real Ethereum network. So don't go crazy. But yeah, our blockchain's running, and we're already connected to this blockchain inside our Truffle project because I have a truffle-config file here that has this already set up, right? So you can just go to localhost, port 7545. That's here. Right here. Localhost 127.0.0.1, 7545. And there you go. We've already got a development network configured right here under Networks tab. So our Truffle project's already talking to Ganache, and what we want to do is add a way to put this smart contract on the blockchain. So remember I showed you this migrations file earlier? Well, this is the smart contract that's responsible for doing that. We need to tell our Truffle project that we want to put this meme contract on the blockchain. So if you go to this migrations directory up here, all right, so initial migrations, we're going to create a new file here that tells Truffle to put the meme smart contract on the blockchain. Okay, so I'll copy this and create a new file. We'll say number 2, deploy contracts. Oops, sorry. .js, not J. And I'm just going to copy the code that was inside of here and paste it like this. Sorry, update the syntax. All right, so it's important that you use number 2 in your file name here for Truffle because it needs to know the order to run the migrations in. So the first migration starts with 1, the second one starts with 2, etc., etc., etc. All right, so we're going to change migrations here just to meme. All right, so essentially what's going on is we're creating a new variable here called meme. And Truffle uses this idea of artifacts to represent the smart contract for the Truffle project. And it's just going to find the meme that we've created here, and it's going to deploy it to the blockchain, right? So I'll show you where this artifact lives. Whenever we ran Truffle compile, it created a new file here inside this ABIs directory, okay? So ABI stands for Abstract Binary Interface, and this could probably be named better because this file isn't necessarily an ABI. It contains an ABI, but this is sort of this this artifact that Truffle's referring to, okay? And it's going to take this file. It's going to know that we're talking about our local network with our truffle-config file, and it's going to use this to put it on the blockchain. So a migration in this case is just moving the smart contract from one place to another, or migrating the state of the blockchain, because what happens, we update the state, all right? So we can run our migration like this, say truffle, migrate, hit enter. All right, it was successfully deployed to the blockchain. So now we can connect to the blockchain and just try it out, okay? So let's open the Truffle console like this. So say Truffle console, hit enter. And what this is going to do is give us access to a JavaScript runtime environment where we can talk to the smart contracts with JavaScript and run commands and, call its functions, read information about it, examine the behavior. Anything you do in a normal console, you can do that with the Truffle console as well with Node.js, okay? So I'm going to I'm going to get a copy of the smart contract, this meme contract like this. Let's say const meme, all right, equals await meme.deployed. All right, hit enter and say meme. Oops, sorry, meme. All right, perfect. So let me explain that. Explain this code. So meme, saying const meme is just declaring the variable, and we're going to sign it whenever we declare it. And we say await meme.deployed. So meme.deployed is the function called on this smart contract meme, and deploy just gets the deployed instance of it, right? So whenever this got put on the blockchain, like it had an address, it has a state, it has all kinds of information, and we need to fetch that out from the deployed instance of the smart contract and assign it to a variable, all right? That's what we do. So this is the meme variable. Whenever we open the Truffle console, it knows about it. We call the deployed function to go find it on the blockchain. Find it on the blockchain, bring it back to us, and assign it to a variable. But if we just did this, const meme equals meme.deployed, it wouldn't work. All right, I can even do it. Well, that's not why. So const meme2. All right, so if I do meme2, my illustration is failing here. I'm not 100% sure why, but I'll explain why I did this. We use this keyword await to say, basically wait for this result to come back. And that's because the deployed function here is an asynchronous function call, right? It doesn't just return the data back, right? We wait for the data to come back. And if we want to do that, we have to use this await keyword, right? You can read more about this in JavaScript if you want to. Let's say here, async await. All right. So let's see here, JavaScript info. You can go read about this. Essentially, it's a strategy for handling the eventual result of an asynchronous function call. You could use stuff like promises in JavaScript and chain them and use callbacks and all that kind of stuff. But async essentially allows you to do it this way: let, then await, promise. Okay. All right. Cool. So read more up on that if you want to. I'm gonna go back to console and say meme. And then let's say get, say const meme hash. Let's not use const, let's just say meme hash. Let. All right. And it's empty, right? It's an empty string. And also notice, if you see this as undefined, right? That's because it just logs undefined out of the console. So sometimes people email me and say, hey, your tutorial doesn't work because I did, await or something like that. Or I can even do await here. Let's just do, sorry. All right, so let's say I get undefined here even when I use async await. Well, that's because the console just logs undefined to the console. You actually have to call meme hash to get the value back, okay? So it's empty. We expect it to be empty because when we deployed it to the blockchain, we didn't assign it yet. So let's call the get function, and that will allow us to update it. So we'll say result equals meme set the hash to ABC123. All right, boom, there we go. So the result is a transaction receipt. We're going to see this more in a minute when we write a test. But essentially, this is the receipt that comes back from the blockchain, right? We can go to Ganache and see that all this worked. We can go to like the logs and the events. Oh, it doesn't see. Oh, it's because we don't have it connected to a smart contract yet. But essentially, if you go look at the logs, you'll see that transaction go through. Okay. But now we can actually read the value back. So we'll say result equals, or meme hash equals await meme.get. All right, let's say meme hash. Boom, there we go. ABC123. Awesome. And this is actually going to be our meme hash from IPFS. Okay, so that's what we're going to use this for. All right, so we've got this on the blockchain. While we're here, let's go ahead and write a test for this, all right? It's really important to test your smart contracts whenever you're writing them for the blockchain because they can't change. And you want to make sure that everything works properly because you can't push your code again once it's actually on the blockchain. So I'm going to create a new directory here to write a test. Clear out some of these files. I'll say new file. Oops, sorry. Project root. Create a new address called test. We'll call this meme.test.js. All right, so test file, test directory, meme.test.js. All right. So Truffle comes with a test framework pretty much for free out of the box. That's going to include the Mocha testing framework and the Chai assertion library. So I'll show you examples of that. Sorry, I'm pulling up examples off screen here. All right, so Mocha is a testing framework. Mocha testing. All right, so mocha.js. All right, yep. And then Chai assertion library. And these are the two pieces of information we're going to use, or sorry, the two libraries we're going to use to write tests for the smart contract. Okay. So we've created this new file like this. The first thing we want to do is import the smart contract for testing, right? Just like we did in the migrations directory. Where is it? Sorry, migrations, deploy contracts. So we'll say const meme. I'm just going to copy this line. Go in the test file. Const meme equal to artifacts.require meme. Okay. Actually, I think that'll work. We're going to find out. So next, we're going to actually import the Chai library like this. Say require. Say Chai. All right. And then let's import some other helpers that we already have here in our package.json file. We see Chai as promised. So I'm going to copy this. This is going to help us write some tests. Say use require Chai as promised. And then we'll say should. All right. So essentially Chai is very configurable, and I'm going to use this configuration to write some neater tests inside this directory. So now let's say we can write the test for the smart contract like this. We use the contract keyword. All right, and then we type in the name, meme. All right, that's this name here. And we're going to pass in the callback function, counts. And we'll write all the tests here. All right, so here's the contract name. The callback function includes the accounts that are provided by Ganache. So we'll have access to all of these inside of here, right? Boom, boom, boom. All right, so now, first I'll declare a variable. Say let meme. All right, I'll say contract. Well, let's say meme, that works. Same name as the contract will keep things less confusing. All right, so inside of here, let's say describe deployment. Let's say async. All right, and inside of here, what we want to do is essentially make sure the contract was deployed correctly and that this test works. Say const address equals, well, let's actually fetch the address, and I'll show you how to do it in the console really quickly. So say meme dot address, right? Whenever you fetched it, we've essentially can log the address from the blockchain, and we're going to check for this inside of our test. Okay. So let's do exactly what we did in the console. Let's just fetch a copy of the meme contract and then show the address. And if it has an address, then we know that it deployed successfully. Okay. So let's just do that and say meme, which we said let meme equals await meme.deployed. This is exactly what we just did in the console. All right. And then we can say meme.address. And we'll just console log the address for now. We're not going to do any assertions. Let's just log it to the console and see if it worked. So I'll open a new tab here. We got a few tabs going. We've got our terminal we're going to run the tests in. We've got our console, and we've got our server running here. Okay. We can check our test like this. We can run it with the truffle test command. Say truffle test. All right. And we didn't create any assertions just yet, but we're going to log this value out to the console just to make sure we wired this up correctly and that the address came back. Okay. All right, sorry guys, I made a mistake. So it says 0 passing. That's because we don't actually have any tests written. I forgot to put this inside of an example, so that's my fault. I'll do it like this. Say it deploys. Sometimes it's hard to talk and code at the same time and like keep your train of thought. All right, so async. All right. Let's try that again. Let's do that. Truffle test, and let's see if it passes. And while it's doing that, I'll explain this a little more. So the describe function here essentially just gives us a way to organize these test examples. You'll see it logged out to the terminal here in a minute. All right. But essentially, like you'll say describe meme deployment, and it deploys successfully. But these, use these arrow functions with async await pattern. And we need these async keywords so that we can call await inside of here and use the await keyword. So if I took this async off, like this await wouldn't work. And I could demonstrate that, but I would just take my word for it. So there we go. Awesome. Perfect. So now we see we have one test. You can see it's a contract meme. That's what we get here. Contract meme. Deployment, right? Describe deployment. And then it deploys successfully, checkbox. And here's the address, right? So that's exactly how it worked. So let's create a test for this. Now, we don't always know what the address is going to be because it's going to change every time we put it on the blockchain. So let's just make sure that it's not empty. That's the best test that we can write. So we'll say assert not equal. All right, so we're using chai for this. We'll say address. All right, the address we got back. We want to make sure it's just not blank. It's not an empty string. Okay. So I'll explain that like on Mocha. You've got, that's what, chai. Chai is an assertion library. So you assert, right? Assert type of foo is string. Assert equal foo and bar. So we're using assert not equal the address of the smart contract empty string. All right. So we're going to do that a couple more times. And we're also going to say it's not null. It's not undefined. And we're also going to say it's not empty address. All right. So this is our test that we're going to write to make sure that it actually got deployed to the smart contract. Deployed to the blockchain, that the address is correct. That's how we know. So we'll say truffle test and wait for this to pass. All right, it worked. So now what we want to do is actually write some tests for these other functions that let's see here, source contracts, meme.sol. We want to make sure that the set function works and that the get function works, okay? So let's just say describe storage, async. I'm gonna say it, updates, or let's just say updates the meme hash. So async. All right, so I'm gonna give myself some space so we can see this better. All right, so what we can do is use this meme.deployed, just like this. Meme equals await meme.deployed to get it, and then write the test example in here. But you'll notice that we'd be doing this twice, right? We don't necessarily want to have this duplication between these test examples. So Mocha will allow us to use something called a before hook or before filter, depending on how you say it. Before, it's just a function. And we can say inside of here, we want to essentially call this, and it's going to run it before each test example, right? So we can fetch a copy of the smart contract and test for meme inside of here in each one and avoid this duplication, this redundancy. Okay, so I can say meme equals await meme. Oops, sorry. Dot deployed. All right, and then that way I can take this out, and then I'll have access to it here as well. And I'll say async, so that we can use the await keyword inside of this. All right. So let's just run the test, make sure it still works after we refactored it. All right, it worked. So now let's actually test that it updates the storage. So first let's write to the blockchain, and then we will read. Okay. So let's do this. We'll say const we'll write a test for that like this. First we want to do is actually store it on the blockchain. We'll call this set function, and then we will call the get function to make sure that it's the same thing that we set it as, okay? So that will make sure that the set function works and that the read function works for getting that information back off the blockchain, okay? So we'll do like this. Say const, well, let's do let, meme hash, all right? And I'll say meme hash equals ABC123. That's just like we did in the console, right? And we'll say await meme. All right, that's the smart contract name. Say set meme hash. Okay, so that's going to actually call this function. Right? Put this meme hash in there. And if this works, this test is going to continue execution. And if it doesn't work, it's going to blow up here. And now what we can do is read it off the blockchain and make sure it's the same as this. All right, so say const result equals await. All right, meme get. All right, so meme hash result. These are the two things we want to compare. It's pretty simple. We just say assert. So we said assert not equal here, so we can just say assert equal. Result meme hash, and then fix that. All right, boom, awesome. So that's all we need to do. Store the meme hash ABC123, add it to the blockchain, fetch it back, and make sure that the result is the same thing that we intend it to. And that's going to test both functions all in one go. All right, so I'm going to kill this dead space and run the test. Hopefully it'll work this time. Trouble test. All right, it worked. So we've successfully written tests for our smart contracts. They're perfectly covered. So yeah, that's great. We finished up the back end portion of our app. All right. So we got a front end that puts the meme on IPFS. Now we have a back end that, is ready to store the image on the blockchain, right? And so we've done that first part. We've put this on IPFS. It's come back. And now after it's come back from IPFS, we want to use this storage contract that we just created and put it on the blockchain. Okay. Awesome. So let's go ahead and do that. We're essentially going to need to use this smart contract, put it in our app, and make it work. So let's do that. All right, so now let's connect this front end to our blockchain. Okay, so go back to our app.js file. Let me find it. Get a little lost here. App.js. All right. So inside of here, what we want to do is actually connect our application to the blockchain. All right. So the first thing we need to do is import the Web3 library. Right. So Web3.js essentially is going to be the library that turns our client-side application into a blockchain application. All right. So I'll pull up the documentation for that here. This is Web3.js right here. It's the Ethereum JavaScript API. So this is going to allow us to connect our application to Ethereum, right? And in this case, we're running Ethereum with Ganache, okay? So inside of here, I'm going to import the Web3 library because we already have it inside this package.json file right here. Let's do this. Say import. Oops, sorry. We'll do import Web3 from Web3. Okay. And that's going to pull in the Web3 library in JavaScript. Now what we want to do is actually wire up this client-side application and turn it into a blockchain application. Okay. So let's talk about how that happens. Okay. So essentially what's going to happen is we need to do two things. We need to make this application a blockchain-based application, which we've already done with Web3. And we also want to have the user to connect to the blockchain with our application. That's what we're going to use MetaMask for, right? So you need to have installed MetaMask in order to follow along with this, right? So what we're going to do is connect with MetaMask to our application, talk to Web3. So we need to wire up Web3, and we can use MetaMask's own instructions in order to do that, all right? So I'm going to reference this blog post that MetaMask put out that essentially, shows us how to do it. I'm not going to reinvent the wheel here. I'm just going to do what MetaMask tells us to do, right? So anyways, I'm going to use MetaMask's instructions to wire up Web3, okay? So I'm going to go here and create a function that actually sets up Web3 and connects to the blockchain inside of this React component, all right? So I'll call it, let's see here, async load Web3. Okay. All right. Inside this function, what I'm going to do is do what MetaMask tells us to do. Say if window.ethereum. All right. Then we're going to do something else. If there is no window.ethereum, window.web3. All right. And then else, we're going to have a fallback. Okay. So essentially, MetaMask has this idea of an Ethereum provider. Okay. And there are some different conventions for that. If it's on window.web3, then we're going to handle it a certain way. If it's on window.ethereum, we're going to handle it a certain way, right? So whenever you use this MetaMask Ethereum wallet and connect to your app, it's going to put either an Ethereum object or a Web3 object into your browser. And that's what we want to do. If it's this, we're going to do a certain way. If it's this, we're going to do it a certain way. If not, we'll say window.alert. Please use MetaMask. And we need users to have MetaMask installed in order to use this Dapp in the first place, to actually sign the transaction to put the file on the blockchain. Okay. So if window.ethereum, we'll say window.web3, which essentially is that's what we're doing. We're overriding it, equals new web3. And we'll pass in window Ethereum. All right, so it's a new Web3 instance. That's what we're getting here. All right. And then we'll say await window.ethereum enable. All right. And if we just have Web3 by itself, we'll essentially just say window.web3 equals new web3 window.web3.current provider. All right. And that's going to be essentially whatever is already attached to window.web3.current provider. All right. And that will be our Web3 connection. All right. So now we actually need to call this function. And I'm going to do it on a lifecycle method within React called component will mount. So async component will mount. All right. And inside of here, we're going to call await this.load web3. So I'll explain that more. Essentially, component will mount is a lifecycle method that comes for free in React. Okay. And what this does is it says, whenever this component is going to mount to, React's virtual DOM, then call this function. In this case, we're going to load Web3. So React knows about this basically under the hood. And we're going to use this function to call another function here in a minute, but essentially that's when we're going to load Web3. It happens before the render function happens. And I believe after the constructor. You have to go look at the React documentation to know exactly when this pops up. You can probably find a list of React lifecycle methods. Let me just look here. React lifecycle callbacks. I'm going to see if I can find it on Google. All right, state and lifecycle. Let's look here. All right, yeah. Yeah, so here's examples. Let's see here, lifecycle. Next. Adding a lifecycle method to. All right, so component did mount, component will unmount. It's probably got a whole list of the methods in here somewhere. Let's just look. Let's see if there's a complete list somewhere. All right, here we go. Here's a good blog post. This is kind of old, so maybe it's a little outdated, but this will give you an idea of what they are. All right, yeah, so will mount, did mount, will receive props, should update, will update render, did update, will unmount. So this will tell you the order and the different behavior based on, what you're trying to do. So in this case, we're using component will mount. So go check out this blog post if you want to learn more about React lifecycle methods. All right, let's go back to our app and see what's going on. All right, so I got a MetaMask notification that popped up whenever we enable window.web3. So this is going to say Dapp University Starter Kit wants to access your app with MetaMask. So I'm going to say connect. Perfect. All right, there we go. We're connected. So make sure you got MetaMask installed and you're logged in, all that kind of stuff in order to connect to Web3. If you don't, make sure you follow the MetaMask setup steps, install the Chrome extension in Google Chrome. You got to use Chrome. And then, make sure you got an account, all that kind of stuff, right? So now let's actually load the smart contract. So we've successfully connected our front-end application to the blockchain. We have a blockchain browser now with MetaMask. And we have a blockchain app because this React app is actually talking to blockchain. All right, so now what we want to do is fetch the smart contract from the blockchain so that we can fetch the value of the meme hash and then actually update it whenever we submit the file to IPFS, and then we'll have a fully functioning backend for this application, and every time we refresh the page, like this won't go away. Okay. All right, so now what we want to do is load all the information from the blockchain, like the account that we're connected with, and also the smart contract for the meme storage so that we can actually read the value of the current meme hash and also update it whenever it comes back from IPFS, all right? So we'll create a function for that. So we'll basically we'll get the account, say get the network, say get the smart contract, and then get the meme hash. Okay, so we need to do all this with the blockchain. So I'm going to create a new function that says async load blockchain data. All right, inside of here, we'll get the account first. We'll just say const web3 equals window web3. All right, so window.web3 was assigned, here. Now we can assign it to a local variable. I'll get the account like this. Say const accounts equals await web3 eth accounts, and then actually let's do this, like get accounts. I'll just show you that in the documentation. All right, so let's go to web3.js, say get accounts. So Web3 has several different namespaces underneath the library. So web3.eth is the package that allows you to interact with Ethereum, right, and the smart contracts. So we can find the get accounts function, right? So what that does is it gets all the accounts in the current wallet, right, and it just returns them as an array, right? So if you have 2 accounts, it's going to show you each, right? So we're using MetaMask, so it's going to give us an array of only 1 account, all right? And we can basically get this account and make sure this is working properly, log it to the console. So let's make sure we have an account in MetaMask, right? I currently do, but you will need to make sure that you import your account from Ganache. So go to Ganache, find that account, show the private key. Now, you don't want to do this for a real account because, this is essentially like your password on the blockchain. If anybody knew this information, they could steal all your money. So don't show this to anybody in the real world, but I'm going to show you the Ganache copy, so that's okay. Because it's not real. All right, so now I'm going to go to MetaMask. I'm going to go to import account. So here, import account. Paste in the private key and hit import. So I've already done this. So it's going to say you're trying to import a duplicate. So I'll click cancel. But once you've imported it, you'll see your new account here. And inside MetaMask, you'll want to connect to Ganache, which is running on port 7545. So that's localhost. Click that. All right. And now I've got 99 Ether in here, which is the same inside of Ganache. So that's the first account on the list. All right. So, all right, let's show this in the console. Oops. Go to the console, go back to our code and say console.log accounts. All right, so it didn't run. I know why. It's because we're not actually calling this load blockchain data function. So we need to do it like this. Await this.load blockchain data. Save that. Boom, there we go. All right, so there's our account returned in the console. That's the same as we saw in Ganache. So E4CB. E4CB. All right, so now I'll copy this. Well, actually, I won't copy it. We need to assign it inside of our code. So do that like this. Instead of, we'll keep track of the current account with the state object, right? So we'll go down here to the constructor. I can't find it. So just below meme hash, well, actually, let's do it first. We'll do it alphabetically. We'll say account. We'll just use an empty string here. We're going to set the account and the state. So we'll say this.set state, and we'll say account equals accounts, which is an array, right? We'll get the first item out of the array like this, account 0. Perfect. Boom. There we go. So we fetched the account out of MetaMask and put it in the React state object. Now we need this account because we want to actually sign the transaction whenever we submit this form to store it on the blockchain. It's really important. We need that account in order to do that. But just momentarily while we're here, we'll display the account on the page like this. Let's just do this. Let's say like, I'm going to scroll down to the nav bar. Okay. And I'm going to, after this link, let's see here. Actually, let's do it here in the nav bar, sorry. After the link, let's create a UL, an unordered list, class name. We'll do this with Bootstrap. navbar, nav, and we'll say px-3 ul, and we'll say li is a list item. Oops. There we go. And inside of here, I'll say class name equals nav item text no wrap d none dsm none, and I'll say dsm block. Okay, so these are just display utilities inside of Bootstrap that say when it should be visible and when it shouldn't be. So now I'll say small, and we're actually going to list out the account here. Say class name. All right, so say this dot state dot count. All right, now let's go see if it worked. Boom, there we go. So now we can see the account that we're actually connected with. It's the same as what we see in MetaMask, right? And it's the same as what we see in Ganache here in our blockchain. Perfect. All right, so now we have the account. Now the next thing we want to do is actually fetch the smart contract and pull it into our app. Let me explain why. Essentially, we're going to find the smart contract, but we need to tell it which network the smart contract is deployed to, and basically, which network we're connected to with MetaMask in order to find it. Because we could, change networks, main Ethereum network, or any of these test networks, or this development network, and depending on which network we're going to connect to, the smart contract could be in a different place. It could have a different address, like we saw, here in our tests, right? So we need to find the network. Now, Ethereum has a way to do that with, let's see here, Web3 ETH. Let's go back and search get net. Yeah, all right, here it is. Perfect. So we can say Web3 net. So Web3, we saw Web3 ETH a minute ago. So Web3 net allows you to interact with Ethereum nodes and network properties. So we can basically just say Web3 net, get ID. And it's also nested under ETH as well. So Web3 ETH net get ID. That's what we use. So the different Ethereum networks have different network IDs, and I'll show you what that means here in a minute. But it's important that we get it. So we'll just say await. Constant network ID was await Web3 ETH get ID, or sorry, net get ID. Save that, console log network ID. All right, let's go look and see what happens. All right, so 5777. Let me show you why that's important. All right, so whenever we deploy the smart contract, we need two different things. All right, we need the ABI, and we need the address. All right, so whenever we open this file over here, this ABI is, meme.json, we need to find the ABI and the address. All right, so the ABI is really easy to find. It's always going to be the same whenever the smart contract is finished, right? We've finished coding it, so the ABI won't change. That's this array here. This basically just describes all the functions on the smart contract, shows us the bytecode, basically just how it works. It describes how it works. And next, we need the address, all right? So this is what I was saying a minute ago. The address will change depending on which network we're connected to inside of MetaMask, right? You'll have a different address here, different address here, here, all right? So how do we find that? Well, we got the network ID from MetaMask with, Web3 net get ID. That's what we just logged to the console as 5777. But you'll see here in Ganache, in Truffle, this file, you'll see this networks key, all right, 5777. So we need to drill all the way down here into networks and find this address right here. And that's the address of the smart contract deployed to the network with the ID of 5777. So if this is deployed to the main Ethereum network, there would be an additional key here that would say 1. If this was deployed to the Kovan test network, it would be called like 42, right? So that's what we'll do. Let's go to here and get the ABI. We'll do that like this. Actually, let's get the address first. Let's see here. Yeah, well, I'll show you. Okay, so I'll just show you step by step. Now that we have the network ID, we can say const network data, and we essentially want to get the we want to get this information out of here. So let's import this file first. Go to the top of our app.js file. And we'll just say import meme from .apis meme.json. All right, so dot just means we're going upper directory. So add components into APIs. And we're going to get this meme.json file here and assign it to this variable. Okay. So now we have this JSON file stored as meme, and we're going to say network data is equal to, let's see here, say meme.networks. All right, that's what's going on here, meme.networks. Oh, yeah, meme.networks, and we'll pass in the network ID. Network ID. All right. So we'll say if network data, then we're gonna actually fetch the contract. Else, window.alert smart contract not deployed to detected network. All right, so let's check that out. Okay, so no issues here, but let's change the network, and it's going to know that the smart contract isn't deployed. So go to the mainnet, and we'll refresh the page. Yeah, boom, smart contract not deployed to the network. Okay, so let's go back to Ganache. Now that's working. And let's change the network, refresh the page. And no error. Perfect. So now we want to fetch the smart contract inside of here that we have the network data. So like I said, we need two pieces of information. We need the ABI and the address. So thankfully we have the network data, so we can find the address because we know the network ID, and we can just dig it out of here. All right. That's going to be network data address. And with ABI, that's going to be just meme.abi. Right? Because it's just right here. Meme. This is the entire file and then ABI. Perfect. I'll even assign that right here. I'll say const ABI equals meme.abi. I'll say const address equals network data.address. All right, just so it's really clear. Here's the ABI and here's the address. Now with the ABI and the address, we can create a Web3 representation of this smart contract, so we can call the functions and actually fetch, the meme hash with this get function from the smart contract. Okay, so I'll show you how to do that. You can go to the Web3 documentation and look for contract. I'll actually look for call. Well, it's not, ETH contract. Let's see what comes up. Web3 ETH contract. Okay, this is how you fetch a copy of the contract. This is exactly what I was saying. Web3 ETH contract, you need to pass in the ABI, boom, and the address. We have both of these pieces of information, and we can do an example just like this right here. Okay, and that's exactly what we're going to do. So I'll go to the app, and I'll create that like this. Say const contract equals Web3 ETH contract with a capital C. And I'll pass in meme.abi network data address. All right, perfect. So that's exactly what I did here. I'll go ahead and use the variables just to be clear. All right, perfect. So we can also update that to the state like this. Oh, sorry. say null, and we'll set state. We'll say contract. Right, that's the same thing as saying this. Right, but ES6 allows us to do shorthand. All right, contract, boom. Now we can say const meme hash. Well, actually, let's not fetch the meme hash yet. Let's just console log contract. Just make sure it works. Go back to our terminal here, or sorry, our console. Let's see what happens when we refresh the page. Sorry. All right, there we go. There's the contract with Web3. So now we're going to be able to actually call the smart contract function. The first we want to call is the get function. Okay. So we do that like this. We go to the documentation. I'll show you how it works with Web3. Let's find the call. All right, here's what we want. So contract call, Web3 ETH contract, my method call. So here's the documentation. So this is how it works. Sorry, I got this highlighting all over the place. This is how it works. So essentially, like, you want to take the contract. So my contract, in this case, will be meme. And then we say methods, all right, then my method. And then you just, put in any function parameters if they have any. And then you say call, right? So there are two types of functions when you're talking to the blockchain. There's call functions and then there's send functions. So call functions just read data. That's all you got to do. My methods, call. And it doesn't cost any gas, right? But send functions do cost gas. And I'll explain that whenever we actually store the file on the blockchain. But for now, we're just going to fetch it. We're just going to read it. And that's what call is for. Okay. It doesn't require any gas. We do it for free. Say await, contract, methods. All right. And then get, right? That's the function here. Get with no arguments. And call. All right. That's just going to return the value because we can't just do get by itself. It won't work. We have to say call. All right. And it's all the methods for the contractor namespace under this methods key. Say const meme hash equals await that. All right. And we also need the await keyword because if we just do that, remember all the calls to the blockchain are asynchronous. This is just going to return a promise. It won't actually return the value. So you could use a promise chain. You could use a callback function. I'm using the async await pattern like we did in the tests. Okay. All right. So now whenever that comes back, we'll say this.set state. Let's say meme hash. So we can add that to, we'll overwrite this. And once we load this data from the blockchain, we're going to see this get updated probably to an empty string or whatever we set it in the console. I think we set it to like ABC123 or something like that. We can just check. Let's see, meme hash. Yeah, we're going to see it set to this. Okay. So this is actually going to break. It won't work. But I'll just demonstrate that on the page. Yeah, look. So it already refreshed. That was our default meme hash. We can see that ceiling cat goes away because it fetched back ABC123 from the blockchain. So I think it's working properly, right? Yeah, here we go. ABC123. Awesome. That's what we want to see. So the image is broken. That's what we expect. But that means that we're actually reading the data from the blockchain correctly because ABC123 is what's in the console. Now I'm going to manually update it in the console so that we can, have, well, I'll just leave it for now. We'll update it from the client side. I don't want to belabor that. I'll show you how it works here in a minute. Okay, so that's all we need to do for this. Perfect. So we've set everything that we need to inside this function. So I'm going to clear out all this code. All right, we're getting so close to being finished here, guys. The last thing we need to do is just store the meme hash on the blockchain whenever it comes back from IPFS. All right. So we've processed the file for IPFS. On submit, we've put it on IPFS. And when we get done, we just need to put the file on the blockchain right here. All right. So let's see here. There's a couple things we need to do. Well, actually, only one thing we need to do. We need to just call this set function and pass in the meme hash. It's pretty easy. So I'll show you how that works. Go back to the Web3 documentation. I'll show you how my method send works. So my method call is just reading data from the blockchain. It's free, all right? It's very simple. You just do that just like we did. my method send works differently. Okay, you actually have to tell it the account that you're sending it from, because that account has to sign the transaction and pay a fee in order to in order to save the meme hash to the blockchain, right? That's because reads from the blockchain are free, writes cost gas, okay? And the gas is going to be expressed in Ether, the Ethereum's native cryptocurrency, in a very small amount, okay? So you do it like this. So contract methods, just like we did the call, my method, you pass in the parameters to the function, and then you say send instead of call. And we're going to pass in some options, which you'll see in a minute. So here's an example. My method send, right? You need to tell the account that you're sending it from. And that's the only data that we're going to pass in. And we have access to that already inside of our application. And I'm not going to use the async await pattern here. I'm going to use a callback function, a promise chain, and say then function receipt. And then whenever the receipt comes back, I'm going to get the actual hash, and I'm going to set the state that way. Okay. So here's what we'll do. We'll say this state contract. All right. So that's what we're doing. We're fetching contract from the state. Got it inside of here because we set it here. Methods set. All right. And then the meme hash, we're going to paste it in. And then send. Here's where we want to tell it the account. So it's a from this.state.account. Right. So that's stored in here. Right. That's the account that we're connected with right here. Right. This.state.account, pass that in. And then we use this promise chain, then, see here, R. And then once that's done, I don't want to update the state just yet. I don't want to do it here. I want to do it whenever it's actually successfully saved on the blockchain. So I'll do it inside of here. All right, perfect. All right, so I think it's going to work. Let's give it a try. So it's got a two-step process. We have to choose the file, change it. Let's change it to our nice Yoda image. And then we'll upload it to IPFS. And whenever it's uploaded from IPFS, it will get written to the blockchain. And we'll see a MetaMask confirmation pop up if everything works correctly. And we'll sign the transaction. Let's click Submit. So it's submitting the form. It's putting it on IPFS. Or it's coming back from IPFS. We should see a MetaMask pop up. So I'll just wait for that. Hopefully it'll submit to IPFS correctly the first time without any timeouts or anything like that. All right, so it actually posted to IPFS. We can see the IPFS result here. And I had a MetaMask confirmation pop up. All right, so here's a MetaMask confirmation. I need to confirm this. I need to sign it with the account, right? Click confirm. And there we go. I got a confirmation. So let's refresh the page and hopefully we'll see our Yoda meme here. All right, it's the moment of truth. Refresh. Awesome. Boom, it worked. That's great. All right, guys. So we have successfully created a blockchain application with IPFS, right? We've got our meme of the day that we can change, put it on the blockchain, and we can show it with IPFS. So it's a decentralized application with decentralized file storage. Congratulations. You've done a lot of hard work to get to this point. Okay, so let's do a little bit of cleanup really quickly. Let's go back to here. I'm just going to take this out. I'm going to take this out because I want to, commit this code so you guys can see it whenever I post the tutorial on YouTube. All right, so refresh the page. All right, boom, there we go. Awesome. Boom, done. Perfect. All right, guys, so that's like our complete app. We've created the smart contracts, you've written tests, you've created a React app, you put it on the blockchain, you've run a blockchain, you've worked with Web3, you've done all kinds of stuff with IPFS. Congratulations on completing this tutorial, all right? So again, if you like this video, be sure to subscribe to the channel, click the like button down below. We've got some source code. And if you want to take it a step further and jump into my blockchain developer bootcamp and build like a real world project with me, you can sign up for that here at dappuniversity.com/bootcamp. I'll take you through a free training and give you an opportunity to join my boot camp. All right, we build a real world project inside there, a cryptocurrency exchange. All right, so we use the same skills that I taught you in this tutorial. We take it to the next level. All right, really next level stuff compared to this, which is a little bit more beginner level. All right, so I'm gonna hope you all like this video, and until next time, thanks for watching Dapp University.